So here's a question that's not dissimilar to past exam questions. We have a whole lot of information, I'll get back to that, and the question is, what is an estimate for beta 1 hat, and the variance for that estimator beta 1 hat. So what have we got here? We have a regression model, y equals x beta plus u, and we need to be quite clear. You need to know what these things represent. Let's assume we have n observations, then that y represents an n by 1 vector with the dependent variables. Then we have explanatory variables n by, and as we'll realize, since the x prime x is 2 by 2, that means we have 2 explanatory variables and therefore 2 coefficients in beta. And our u vector is n by 1. So we know that from the result of this x prime x calculation, that is 2 by 2, and that comes because we multiply x prime, which is 2 by n, with an n by 2 matrix. So we also need to understand the beta. If you have 2 columns in x, then the beta will have 2 values. We call them beta naught and beta 1. That's a 2 by 1 vector. It turns out we are after that beta 1 later in the question. So let's understand what this x is. Well, basically formulating a regression model in matrix form, and since we have a constant, the first column will just be represented by 1s, and the second column, let's say our explanatory variable is age, then we have the age of the first observation, the second observation, all the way up to the nth observation, the age for the nth respondent in a survey, say. So the formula you always need to remember is that the OLS estimator in that regression model, beta hat, is x prime x inverse x prime y. Now we are given all sorts of information, and basically we are given these 2 blocks, x prime x inverse and x prime y. And let's call them just for short B and A here. That's the information we have been given. And you should remember how to calculate the variance for beta hat. That's s squared times x prime x inverse. Now B we have, and S, that is the estimated standard error of the regression residuals, we have also been given. So we have all the information we need to calculate both beta hat and the variance for beta hat. So let's start. From now on, it's just technical stuff. So we have to calculate x prime x inverse times x prime y. And x prime x inverse is just that B matrix. So let me replicate that matrix here. That's just the value of the B matrix. And we multiply that with x prime y. We do that in that slightly funny form that simplifies the calculations a bit. I put up here that A matrix that represents x prime y. And now I realize that the outcome of this is going to be a 2 by 1 matrix. And since we are after beta 1, which is the second element, we really only need to calculate that second element here. And how do we do that? We multiply negative 0.01001 with 40,293 plus the product of these two other terms, 0.02309 times 18,616. The result of that is approximately 26.45. You may get slight rounding errors. So that means we know what the second element of beta hat is, and that is beta hat 1. 26.45, we answered the first question. Now we want to know what the variance for beta hat is. Now s squared, that's a scalar, a 1 by 1, and x prime x inverse is 2 by 2. So the outcome of this is going to be a 2 by 2 matrix. And it's important to understand what this 2 by 2 matrix represents. In the 1, 1 element, we will have the variance of the first element of beta. Here we label that beta naught, so variance of beta naught hat. And that is the variance of beta 1 hat. And in the off diagonal, we have the covariance between these two estimators. And our question asks us for that element, the variance of beta 1 hat. So all we need to do is we need to pick the 2 element of x prime x inverse and multiply that with s squared. So we have 6.182 squared times the 2 element of x prime x inverse, 0.02309, and the result of this is 0.8824. Okay, so that is the variance of the OLS estimator for beta 1 hat. And we answered our question.